Okay, Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Today, I want to discuss about differential. Before I start, I want you to know this presentation was made by my course lecturer named Mr. Ede Mehta W from Department of Marine Engineering. But this presentation has been modified by me. So, let me introduce myself. My name is Nur Abdurrahman Alwinari Suryaputra. You can call me Hayat. My student number is 4216021 from Marine Engineering Department, Institute Teknologi 10 November, Surabaya, Indonesia. Okay, today's topic. Today's topic is differential. As you know, differential is very soluble in real life. For example, if we have some function of distance, then we want to find the velocity and then find the acceleration and so on. We can use differential to solve the problem. This is very useful. So this is the basic formula from differential. Fx in x 0 or fx in x is the function that has been differentiated. So fx in x equal to limit h goes to 0. F in bracket x 0 plus h minus fx per h. So these are two examples. For the first, d per dx multiplied by c or constanta, and then the second, d per dx multiplied by x power to the power of n equal to n multiplied by x to the power of n minus 1. For the first example, fx equal to 5, d per dx multiplied by the function is 5, equal to 0. Why it equal to 0? Because 5 is constanta, there's no variable there. Different in second formula, fx equal to x to the power of 5, d per dx multiplied by fx, and then if we use this formula, this is the simple formula for differentiation. M multiplied by x to the power of n minus 1. So the 5, we can put the 5 in front of the x, or the 5 become the constanta. But don't forget of the square. 5 should be minus by 1. So the differentiated function equal to 5 multiplied by x to the power of 4. This is same like before. This some regulation for using differential. If we have two functions in a group, for example like this, d per dx in a bracket fx plus gx. So how we find the differentiated function? The differentiated function separate into two differential functions. So like this, d per dx times fx plus d per dx times gx. You can look at this in bracket, these two functions connected by plus. In this also, connected by plus symbol. So just go to the just just go to the example. For fx equal to x to the power of 4 and gx equal to x squared. If we use this formula, this regulation, we use this regulation. So the way to solve this problem is like this: d per dx times x to the power of 4 plus d per dx times x squared. And we use the second simple formula for the differential. 4 become the constanta and the square minus by 1. 4 times x cubic plus, and then 2 become the constanta and the square must minus by 1, so the differentiated function become 2 times x. So this is the differentiated function. This also, but this is different. Before we use this function, these two functions are connected by plus symbol, but this function connected by multiply function. In the bracket, there's two functions connected by multiply, fx times gx. So this is the formula, the regulation I mean. For the first fx, we not differentiate the fx, just basic fx times differentiated gx, then connected by plus, and then basic gx times d per dx, or I mean differentiated function of fx. So this is the example. Same like before, fx equal to x to the power of 4 and gx equal to x squared. D per dx, yeah, using this regulation. So use the basic fx equal to this basic fx equal to x to the power of 4, and then times the differentiated of gx plus, and then connected by plus, then basic gx times differentiated function of fx, and the differentiated function become like this. Before we use different this differentiated function connected by multiplied, but this one using divide, two function divided. If we have two functions, the first function divided by second function, then we use this formula: basic gx times differentiated function of fx, then connected by minus, then fx times differentiated function of gx per gx squared. Where we get this has been simplified from the basic formulas of differential. So here we come to the example. Yeah, same like before. If you're confused, you can pause the video. We can pause this video and then understand it slowly. If you still don't get it, you can ask in the comment. Okay. This is the differentiated function of trigonometry, the differentiated function of sin x equal to cos equal to min sin, and so on. Just pause this video and you will get it. So this is the application in real life. Example: if there's a rock falling freely from rest near to the surface of the earth, and we know that the rock fell with rate y equal to 16 times t square feet during the first t seconds, and we use a sequence of average rates over increasingly short intervals to estimate the rock's speed at the instant t equal to 1. What was rock's exact speed at this time? So this is the solution. The solution using the basic differential formulas. You can read. We let ft equal to 16 times t squared, the average speed of the rock over the interval between t equal 1 and t equal 1 plus h seconds. For h more than 0 was found to be like this. F in bracket 1 plus h minus f1 per h equals, so 16 times 1 plus in bracket 1 plus h square. This is the function of 60 of ft. See, you can see here, just change the t with 1 plus h, just 1 plus h, just input to the t, and then minus 16 times 1 square per h. Then you can calculate, you will get the differentiated function 16 times h plus 2. Then the rock speed at the instant t equal to 1 is then limit h goes to 0, 16 times h plus 2 equal to 16, and then 0, just input the h, just input the 0 to the h, and then we get the speed equal to 31 feet per second. Okay, if you still don't get it, you can stick to the previous example and pause the video, and you can understand it slowly. I remind you, if you still don't get it, just comment below, and inshallah I'll answer it. So this is the second exercise. A failure on container chain makes those containers fall from the top of a 30-meter container. Its age above ground after t seconds is 30 minus 4.9 times t squared. How fast is it falling 2 seconds after it's dropped? So this is the solution. We write the function f(x) equal to 30 minus 4.9 times t squared, and then we use the simplified formula for differential. So we get the differential function equal to, yeah, minus 9.8 times t, and then we have to find the velocity. Velocity equal to first differential of the function. If we want to find the acceleration, just differentiate differentiate the first differential function. Or if you directly want to find the acceleration, you have to differentiate the function, the basic function, twice. But this question just asks for the velocity, so we just find the first differentiated function. We already get the first differentiated function f action x, and then just input 2 to the t. Sorry, I mean this x must be should be t. I'm sorry for the mistake. So the f action 2 equal to minus 9.8 times 2. 2 has been inputted to the t. Then we get the velocity equal to 19.6 meters per second. This minus, it means go down. Okay, there's no other slide. So this is the end of my discussion. This is the end of my presentation. Thank you for watching. Hope you like it. Hope this help your problem. Please like and comment below. I remind you, if you still don't get it, if you still don't understand, just comment comment below, and inshallah I'll answer it. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.